What is time? This is a curious question that has been asked repeatedly throughout history. Some say it flows at a constant rate, while others say it is variable, like Albert Einstein. He determined that physics laws are the same for all constant observers, and the speed of light in a vacuum is independent of the observer's acceleration motion. Thus, he gave us the theory of special relativity. He spent 10 years making acceleration a part of his theory. He determined that huge objects could cause distortions in space and time. His calculations determined that the space time fabric is distorted near bigger bodies. Take the trampoline example, for instance. If a heavy metal ball is placed in the center of a trampoline, it will stretch the fabric downwards, creating a dimple. Now, imagine that the trampoline fabric is the space time fabric. If a marble is rolled towards the heavy metal ball in the fabric, it will launch with higher acceleration and slow down toward the dimple. Even if it passes the heavy metal ball, it will roll back to complete the orbit, eventually collapsing into the metal ball. This is how time works in outer space. It slows down near the heavy objects and moves faster in a vacuum, where no forces such as gravity are exerted. The same way the gravity of our sun, Earth, Moon, and other planets work. The gravity of a planet pulls at rocks in space. Mercury's orbit is shifting very slowly over time due to the curvature of spacetime around the massive sun. It could even collide with Earth in a few billion years, just like a small marble collapses into a bigger, heavier metal ball. Space has always been taken for granted by humankind. The empty backdrop with flickering lights with no limits, no ends, and no beginnings. Time, on the other hand, strikes on incessantly. And if physicists and scientists have learned anything from the long debate to unify their theories, it is that space and time together form a complex system that may defy our most adherent efforts to understand. Albert Einstein saw what was coming as early as November 1916. A year earlier, he had formulated his general theory of relativity, which described that gravity is not a force that propagates through space, but a feature of space-time itself. When you throw an object up into the air, it arcs and falls back to the ground. This is because Earth distorts the space-time around the object, so its paths and the ground intersect again. Einstein explained the challenge of merging general relativity with his other brainchild in a letter to a friend, the promising theory of quantum mechanics. He believed that you would not simply distort space, but dismantle it. Mathematically, he hardly knew where to begin. He even wrote, "How much have I plagued myself in this way?" Special relativity is ultimately a set of equations that relate the way something looks in one frame of reference to how it looks in another. The stretching of time and space and the increase in mass. The equations evolve nothing more complicated than high school math. General relativity is more complicated than this. Its field equations describe the relationship between mass and the curvature of space and the dilation of time. These studies are typically taught in graduate level university physics courses. On the other hand, absolute space has its own separate nature without any relation to anything external. It always remains similar and immovable. Absolute, true, and mathematical time, and from its own nature, flows equably without relation to anything external. This concept of time seems natural enough for us to accept almost without thinking. But what if the universe was only a great big clock? Or if time, as we know, was not related to anything else but itself? Every concept of time that we can think of is deeply connected to a concrete, physical event. The swing of a pendulum, the vibrations of a quartz crystal, the orbit of the Earth, the quantum leaping of atoms, the motions of magnetic and electric fields, the lives of suns, lunch with your friend, and on and on. Without such events, what would time consist of? You can't have time in a void because there would be nothing to relate it to. Time makes sense only when it is connected to something. To understand this better, we will have to focus our imagination on one of the tiniest particles in the known universe, the atom of hydrogen. The atomic year of hydrogen is 10 to a minus 16th power, which is infinitely short compared to a year on Earth. Yet, the atomic year is incredibly long compared to many nuclear particles' lifespans, which are millions of times shorter. The timescale at this microcosmic level is often counted in nanoseconds. Another area where we can see time measured this small is inside of a computer. For example, it may take a signal 12 nanoseconds to get from one place to another, which in some cases is a long time, but also noticeably short when compared to a snap of your fingers. So, where does relativity stand? The question remains, if we were to grow 1,000 times bigger in mass, would days get longer? Or would the years carry on the same, or become shorter? Is there even something as time? Or is it just gravity playing its role? And have we named this phenomenon time just to keep track? No doubt it took Einstein 10 years to come up with his theory. What are your ideas about time? Please share your thoughts with us in the comments below. I hope you enjoyed today's video. Don't forget to leave a like and subscribe to the channel, and I will see you in the next one.